Good evening guys, this is Sumaiya. Welcome back to my YouTube channel. Today in this video we are going to discuss a very important topic, photometric curves. In this tutorial I won't be giving you any textbook definitions. Instead we will focus on understanding what photometric curves are and how we as lighting designers can use them effectively. Let's get started. So what is photometric curves? Photometry or Cartesian curves or polar curves all are same. They are used to describe the distribution of light from the luminaire. Now what are the key information we can get from the photometric curves? We can understand about luminous intensity distribution, symmetry of light, directionality of light, and its beam angle. In this video we are going to discuss few steps on how we can read this information from the photometric curves. Now when I ask you to say the beam angle of these three images, I'm sure you can easily say me what are the different beam angles. This one here is spot optics, this is medium optics, and this is wide optics. Wide beam angle, optics and beam angle is same. Plus if I ask you about the directionality of the light, you would say me, Sumaiya, all three angles are same, like all are down lights and the direction of the light is towards down. All the lights are downwards. Now if I ask where the luminous intensity of the light is high, you would say me, here the luminous intensity of the light is high, and as we go away from the light source, luminous intensity decreases, and this luminous intensity is measured in candelas, right? So if light distribution is shown in the image format, I'm sure you can easily tell me the data, okay? But if the same thing is representation as photometric curves, then it might get challenging. But the thing is, both are same. The only difference is this is an image format and there we have it in a diagram format. Now let's check that out. Consider the four quadrants or the four axes, x, y, x dash, y dash. Or you can say it as 0 to 180 and 90 to 270. Let's consider a graph of x and y axis, wherein x axis I have from 0 to 180 degree and on y axis I have 90 to 270 degree. This axis I will say it as C0, C90, C180, C270. If I place my round protractor on it for easy understanding, these are only my angles 0, 90, 180, 270. Right? Now this is going to help us in understanding the CR planes. Let's go to Dialux to simplify it further. Now here in Dialux I have imported the same round protractor image for understanding, wherein I have a scale from 0, 90, 180, 270. We will refer this as C0, C90, C180 and C270. Okay, let me place the luminaire. I have placed the ULD file. Let's view it in 3D. Now to see the photometric curves or the light output of this light distribution curves, you can go to the display options. Here, show light distribution curves. Click here and your light distribution curves are visible. Now we discussed about this graph C0, 90, 180 and 270. Same thing we have imported. When you are viewing from the top, okay, this red indication what you have here, that is your x-axis. Okay, so that is C0 to 180. Now in your photometric curves, see here it may be mentioned as C0 to 180 or C90 to 270. So what is C0 to 180? When you are here, it is C0 to 180. That means I need to view the photometric curves from this side. C0, C180, you can see the light distribution. It is like this. Okay. Now for C90 to 270, 90 to 270, I have to view the light distribution curve from this side. Okay, so I will rotate it. Now I have C90 to 270 and I will view from this side. Okay, and now when you view from this side, you have more circular light distribution curve. Okay, so you have two curves. One is from C0 to C180, this one, and next is C90 to 270, this one. Let me draw the CR planes. Okay, we have the axis C0 to C180, right? So I'll draw from C0 to C180, and here is my light source, and the light distribution curve when I'm viewing from C0 to C180 is something like this, right? Now let us draw for C90 to 270. I'll keep this aside. We have an axis here. This is from C90 to C270, and when I am viewing the light distribution curve from this side, my angle is somewhat more circular, right? Now I have these two light distribution curves, and we are going to place this curve one above the other like this. So here you have two graphs. One is of C0 and 180 and other is C90 to 270. This is what you have in the polar curves. When you have two different curve shapes, that means your light distribution is asymmetric. It is not same on both the sides. Viewing from C0 to 180 and when you're viewing from C90 to 270, you have different beam angles. That's why you have here two curves. Hope this point is clear about C planes, that C0 to 180 we have this light distribution, and C90 to 270 this is the light distribution, and when we are merging both we have one graph. From this you can easily say me that is having a symmetric beam angle because both are different. Okay, if it is symmetric it will be having the same distribution, light distribution curve from both sides. Let us see that example as well. I'll go to the Dialux. I'll place one downlight here. Okay, I have placed the luminaire. Let's go to the 3D. See, if when I am viewing from C0 to C180, this is the graph I have, the light distribution, and when I am viewing from C90 to 270, that is from this side, this is the distribution. Both sides it's same. See, it is same both side. So this type of beam angle, it is symmetric. But the one which we had earlier, which is this one, this is asymmetric, because when I am viewing from this side and this side, both are not equal. Okay, I hope this point is clear. Symmetric and asymmetric beam angle. By this even you can say me the directionality of the light. Now this is the downlight and the light distribution curves are pointing towards downside. Okay, let us understand this directionality with the example of a wall washer light. When I use the IS file of this wall washer downlight, you can see that the light distribution curves are more towards the right side. Okay, so the directionality is this side, more at C0 plane, and when you view it at the 3D you can see the curve. Okay, it is more towards this side. That also because it's a wall washer light. This is how the light is emitting. This is not straight towards the down, it is more towards the right side, towards C0 angle. Okay, if you have this kind of polar curves, you can find it for wall washers, for wall washer, or maybe even for directional lights. This is easy to understand by just seeing the graph. Now let us understand the next very important topic, beam angle, to read the data regarding the beam angle from this polar curves. For beam angle, let us consider a light source and let us draw a normal line. Okay, I have drawn here two lines. One is x-axis and one is y-axis. On x-axis, we will consider it as a normal line. For y-axis, it is from where the light is emitting. This is downlight, so light will emit towards downwards, right? So I have drawn my y-axis in that direction itself. Now, to measure the beam angle, what you have to do is from this y-axis towards normal, okay, anti-clockwise direction, okay. That will be from the angle will be, if you use the protractor, the angle will be 0, 30, 60 and 90. And for this side, you are not going to continue it like a round protractor as for CR planes. Here it is bit different, so watch this step carefully. Here from the normal, we are going to calculate the angle in clockwise direction here. So it will be 0, 10, 0, 30, 60 and 90. Okay, so here it is from the y-axis we have 0, 30, 60, 90, and then from here this side we will go 0, 30, 60, 90. You might get confused while seeing your IS polar curves that here also it is 90, here also it is 90. How is that possible? It is because the beam angle we are calculating in two ways. One, this is the line from the light source, and first side we are going to calculate from C 0, 30, 60, 90, and on this side we are going to calculate as 0, 30, 60, 90. That is why when you see here it is 90 and 90, don't get confused. This is how you're going to read the angles. Now to read the angles, it is very important to understand the luminous intensities. Okay, that I will show you with the help of one light source. We will try to understand light intensities with the help of the light. At present I have only this ring light with me handy, so I'm going to use the same source. Assume this is your downlight, okay, and this is your downlight. Assume this is your downlight, and from here is what we have drawn. How is the light effect? It is towards this side, that is where my axis is there, and then we have here one more axis, that is our normal. Now tell me, where is the light intensity more? The light intensity, the intensity of light is more at the source. As we come down, okay, as we go down, the intensity of the light decreases. If I need to explain you in simple terms, you can say it brightness. Okay, brightness is more here, and as I move towards downside, the intensity is decreasing. Okay, and somewhere here the intensity is half. Okay, this is important for us to understand the beam angles. We are going to say it in the graphical representation, but now I hope you understood what are light intensities. Light intensity with this small example. Let us resume back to our graph. Here I have marked the different angles 0, 30, 60, 90 on this side, and 0, 30, 60, 90 on this side as well. I will place the image of my light distribution curve here. Okay, how I'm going to calculate? I have the axis here. From here I'm going to, my scale is like this, right? So I'm going to measure the angle once at this side, once at this side, and then I'm going to add both. Okay, take the polar curve of the same downlight. Here we have one line y-axis here. Highest intensity point is this. We are going to measure the angle from the half intensity point. So in the example I showed you, the half intensity is somewhere here. Highest intensity is at the source. Okay, half intensity is somewhere here. This is the curve. I'm going to measure till here. I'll mark this point. So the axis is 30. The angle this is making is less than 30 here. Okay, maybe it is 26. Okay, and one side, and we need to measure this side as well. This is the axis. From here 0, this angle is 30. Half intensity point is somewhere here, and when I mark a point here, it is less than 30. So that means this is somewhere around 26. So if I add 26 plus 26, my beam angle is 52. Right, see here, beam angle 52 degrees. So this is how you're going to calculate the beam angle from your polar curves. Let us see our other example which we saw earlier for the asymmetric beam angle. Okay, here we have two curves. One is with this blue line and other is with red line, and we are going to calculate beam angle for both. Because it is asymmetric, we'll calculate for C0 to C180 this photometric distribution one beam angle, and next we have another this circular shape red colored line, dotted line. For this too we are going to calculate the beam angle. Let us calculate first for this blue line cyan, because we know that this is for C0 to C180, right? Now this is, we are going to calculate this side here. This is the highest intensity point. Half intensity point will be somewhere here, and if I mark this, it is over here. This angle is 30, and maybe this is somewhere around 40. Okay, and now similarly I'm going to calculate at this side. This is C0. For this side, half intensity point is somewhere here. This is my 30-degree angle line. It is more than 30 degrees. Maybe it is around 40. So 40 plus 40, 80. See here, it is 81. Okay. Now similarly we are going to calculate for this red line. Okay. From 0, this is the highest intensity point. Half intensity point would be somewhere here. And if I mark from here to here, this is the point. C30 is here. C60 is here. So the angle here it is making is of maybe 50 degrees. Then similarly we are going to calculate here. Half intensity point for this is this point. Okay, so it is more than 30 and less than 60. 30, 50, 60. So 50 plus 50, 100. So your beam angle is 104. Okay, this is how you're going to calculate the beam angles. Now, what are these circular lines? This circular lines is nothing but your distance from the source. So from here, this is the highest intensity point, I said, right? And as you go downwards, the distance increases. That distance is only your circular line. For practice, take an example of 4 to 5 luminous. Go to their data sheet and try to analyze the data from their polar curves. These polar curves are very important. You can analyze the data with your CR planes, right? So this is it guys in this video. Hope you have found this video helpful. If you did, please do hit a thumbs up, subscribe to my channel and stay tuned to explore more in Dialux with me. Thank you.